Today's video is about a simple PWM circuit based on the popular 555 timer IC. So this is the circuit diagram, very simple with very few components. We have the 555 timer, two capacitors C1 and C2, two diodes D1 and D2, a potentiometer and a resistor R1. The way this circuit works is that the capacitor C1 gets charged through the resistor R1, diode D1 and through the potentiometer. Once it's charged to a certain voltage, it is discharged through the other side of the potentiometer, this time via the diode D2 and to the pin 7 of the IC, which is the discharge pin. When the capacitor is being charged, the IC pulls the output pin 3 high. Once the capacitor is charged to 2/3 of the supply voltage, the internal comparator triggers the discharging of the capacitor. During discharging, the IC pulls the output pin to ground. When the capacitor is fully depleted, the discharging stops. The capacitor starts charging once again and the output gets high. This whole charging and discharging process repeats again and again, and we get a square wave output at the pin 3. By changing the charging and discharging time using the potentiometer, we can change or modulate the pulse width, hence the name PWM or pulse width modulation. Since the charging occurs via the resistor R1 and the potentiometer, we want the value of R1 to be very small as compared to the potentiometer to be able to achieve a very small pulse width or a duty cycle closer to 0%. As the pin 7 connects to the collector of a BJT in the IC, during the discharge process, current will also flow through R1. If value of R1 is too small, large amount of current will flow through it and the internal BJT of the IC, which will waste power and put unnecessary strain on the IC. These are the components for the circuit. We have the 555 timer, a 250 kilo ohm potentiometer, a 1K resistor as R1, two FR207 diodes as D1 and D2. You can use any Schottky or fast signaling diodes like 1 and 4148. A 10 nanofarad capacitor as C1 to get a higher frequency. A 100 nanofarad capacitor as C2 between pin 5 and ground. I'm adding a IC socket for the IC, and now it's time to add rest of the components. A female header for the potentiometer to which male headers are also connected. And in just 10 minutes our circuit is ready. I have also added these connection points for output and power. And after adding a LED between the output and ground and giving the circuit power using a 3.7 volt battery, we can see that our circuit works very well. Now let's say you wanted to connect a bigger bulb, but the IC can only provide up to 200 mA on the output. For a higher current, we need to add an N-channel MOSFET or an NPN transistor to the output. But our supply voltage is just 3.7 volts. So MOSFETs like this IRFZ44 won't work as it requires a higher gate voltage. Of course I can use an NPN transistor, but the collector emitter voltage drop is too high in a BJT. What we need is a MOSFET with a gate voltage closer to our supply voltage. One such place to find it is the TP4056 charging module with the discharge protection. This IC right here is the 8205A, which is a dual N-channel MOSFET IC with the gate threshold voltage of just 1 volts. So I soldered it on a piece of power board and connected it to our circuit with a suitable gate resistor. The bulb is connected between the drain of the MOSFET and VCC. After powering the circuit, we can see that it is working just fine. But now you want to control this DC motor. For that, we need this diode connected in reverse between the drain of the MOSFET and VCC, because the coils in the motor will store and release energy in their magnetic field, resulting in huge voltage spikes which can damage the MOSFET. This diode dissipates that energy and protects our circuit from those voltage spikes. So after adding the diode and connecting the motor, we can now efficiently control the power going to it, and thus can control its rotation speed. So that's it for today's video. If you liked it, then please give it a thumbs up and subscribe for future videos. And once again, thanks for watching.